already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Not looking back, eyes on the freeway, Bonnie and Clyde, a classic cliche. We're on the run, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out, done with my own doubts.
Hello, good evening and welcome to our first revision session for AQA A-Level Geography for 2026. So tonight we are revising the water cycle. We've got 14 of these sessions planned and they're going to happen at this time each Wednesday, with the exception of a few weeks where our very busy team are entirely away, so I've got no presenters whatsoever. And there might also be the occasional change of time or day due to presenter availability, but we will let you know in advance of those. Anyway, my name is Vicki. I am the subject lead for Tutor to You, and hopefully you will recognise me if you've watched some of our videos in the past. And I have got Catherine on screen, who you may also recognise because she's a regular presenter of ours, and she is also geography royalty, which you'll be really embarrassed that I'm saying, as she is our current president of the Geographical Association, which obviously is very, very impressive. So she is a proper subject expert and a proper physical geographer as well, which is really handy, as obviously tonight we are looking at the water cycle. Before we get started this evening, I just wanted to remind you, and hopefully you know this already, that as well as these weekly live revision sessions on Instagram, we've got a range of revision guides available on our website and on Amazon. We've got our daily revision questions on our Instagram page, which I've popped the link of, or the Instagram handle in the chat. And we've also got our cinema grade booster workshops coming up, which myself will be presenting. I've also got Catherine, some of them, and some brilliant presenters also. So as usual, we are going to do a range of activities, alternating between Catherine and myself. We haven't got a second presenter today, or a second co-presenter. It's just me and Catherine. And I'm to be fair, I'm not really sure why I haven't got the two screens up, Catherine, rather than just the three. It's obviously automatically come up without me realising. As usual, once we set up a question or an activity on the screen, if you can pop your answers in the chat and we can sort of respond to those, And if you have got any questions relating to the topic, then you can ask us as well. And we've got 50 or so of you watching now, which is absolutely brilliant for our first live session. And I think, Catherine, we're starting with you, aren't we, with our first activity. So I will pop the PowerPoint on now.
Brilliant. Well, I'm absolutely delighted that we've got so many joining us today. That is wonderful. And Vicky likes to give me this one because she knows that I am the only person who is silly enough to have a go at actually trying to say the words when they have alternative vowels. So we're thinking about the water cycle. And we're thinking here about some of the key terms. This is really important because when you're looking at the AQA exam paper, you've got the first questions are always going to be 4-mark questions. It's going to give you a term and you're going to have to outline it or explain it. And so you need to make sure you know all of the terms on the specification so you can get those first 4 marks really easily. So what's happened is we've got the key terms, but a vowel has been changed to a different vowel. So maybe an E has been swapped with an A. So can you work out the key term? They start off quite easy and then they get a little bit trickier. So Vicky, let's have our first one up. Okay, so pop in the chat when you've worked out what Dronogo Bosson, or that sounds like an exotic name, I think, some sort of singer from some far off location. Drogona Bosson. What could that be if we swapped out the vowels? Looking forward to seeing your answers coming in on the chats. Now, let's see who can get there first. What term could this be that's to do with the water cycle? Right, okay, so, very good. We have got lots of people coming in now with drainage basin, and I'm pretty sure that's going to be the right answer when Vicky reveals it. Brilliant. So drainage basin, the area of land that surrounds the river and the water that's falling as precipitation within that area is going to flow into the main river. That is brilliant. Too many people for me to mention all the names, but I think Doody Daniel got that one. Oh no, that was saying hi first. It was another Daniel that got the answer first, I think. So absolutely brilliant. On to the next one. Right, okay, so what could this be? I can say the broom bit at the end there very easily. So what could that be? A really important term. What could we say that is? Let's see. Dynamic equilibrium. So let's see. Is it going to be Daniel that's going to be first again? Or who is going to be getting in there? Oh, this time we have got Doody Daniel getting in very quickly. And we've got Soccer Fan there. Brilliant. Loads of people getting dynamic equilibrium. Yeah, another really important term thinking about when we have a system in balance. Okay, your brains are definitely getting warmed up now. Fantastic. On to the next one. Right. So, oh my goodness, Vicky. And I've got to try and pronounce this one. So, I've Patrien Speretian. Feels like I'm speaking a different language. So, what on earth could this extremely long word be? I've Patrien Speretian. So, let's see if you can be super brainy thinking about this term as well. There's a lot of vowels in that one to change. And right, okay, this time I think it was Helen who was first up with the answer there. Fantastic. Very good stuff. Evapotranspiration. And I think we're going to come back to a bit of evapotranspiration later on in the session as well. So fantastic stuff. Okay. Oh, now this one, I think you're going to work this out quite easy, but it is something that when it comes up in exam questions can often throw people. It's one of those little terms that sometimes people miss when they're revising. So Witterbodgut. So Witterbodgut, what could that be if we're thinking about a key term? What do you think? So right, and we got Doody Daniel again on water budget, and Harry straight behind talking a bit about water budget. Brilliant. Lots of people coming up with water budget. So like I say, water budget, we could figure that out quite easily on the key terms, but when you're revising, make sure you've got that granular revision, which means that you are going to be looking at terms like that and make sure that you understand about the water budget and what you've got going on over different points of the year with the balance between precipitation. I'm changing the vowels myself now. Precipitation, and thinking about evapotranspiration and thinking about soil storage. So just adding it in there because Soccer Fan there is saying that they didn't know that one. But have a little look it up, and you'll be able to see it's all about that balance between the different inputs and stores over the course of a year. Well done. Okay, infiltration. So what could that be? Does make you think about all these very long words that we have. But I think you're going to get this one really quickly. What do we think this is going to be? Okay, so who's going to be popping up on my screen really quickly with this one? That is ridiculous, Harry. You were so quick. That is absolutely brilliant. Wow, really? And then we got Daniels, we got Mia, got loads of people coming up with infiltration. Fantastic. Because when we're talking about the water cycle, and we got carbon cycle that we're looking at in 2 weeks' time, we're always thinking about the systems approach. Absolutely underpins everything that we do on the water cycle and carbon cycle. And you need to be thinking about all these different flows and thinking about different stores. So that is really super, really good thinking about those keywords. Right, so we're over to Vicky for this one. Well done to everyone. Really appreciate that you're putting so much in the comments. That's great. Are you there, Vicky?
Sorry, I just seemed to have muted myself there, and I didn't realise I had. So I had started to introduce the activity, and for whatever reason, my microphone had gone on to mute. So we have a categorised activity. You're going to have a timer that counts down for a minute. There should be some quite dramatic music on here. I can hear the dramatic music at my end. It doesn't always come on across onto the screen though, so hopefully, Catherine, if it doesn't actually come on, can you just give me a wave to let me know there's no music, and then I can do a bit of talking instead.
Okay.
There are 8 different statements that need to be popped into either positive feedback or negative feedback. What we would like you to do is just to pop positive or P, and then the numbers that go with positive feedback into the chat, and then N for negative, and the numbers that go with that. And obviously there is quite a lot to read there, so I'm going to set off the timer now. And hopefully you've got some music.
Yeah, we have dramatic music.
Beautiful.
Very dramatic. Woo!
Fantastic. So we've got a number of you that have popped number 1 into positive feedback. We've also got some of you popping number 2 in. And then we have a Doody Daniel has done a very good job here. So we've got down positive 2, 5, 6 and 8 and negative 1, 3, 4 and 7. So let's see whether you are correct. Okay, so unhelpfully it hasn't put it into number order, but that doesn't matter particularly. So positive feedback, we have got number 6. So the rise in temperatures here leads to increased evaporation, which then leads to more atmospheric water vapour, leading to an enhanced greenhouse effect, which creates further warming. We've then got number 8, glacier and snowmelt, which leads to a reduced albedo, and then more solar energy is absorbed as a result. That leads to further melting. We've got number 2, droughts, which then leads to reduced vegetation cover, leading to lower interception and evapotranspiration, which then leads to reduced precipitation, and that leads to intensified drought. And then at the bottom, we've got deforestation, reduced transpiration, decreased atmospheric moisture, which then obviously reduces the rainfall, and that causes further drying out of the system. So we remember, positive it isn't always positive, it amplifies change. So in this case, it's obviously quite a negative thing here. It's creating more warming, or it might be creating a more intense drought in the examples that we've got on the screen. If we then think about negative feedback is all about reducing change and restoring that balance, and it then restores the system back into a stable state. So we think about those inputs and outputs, they're constantly changing, but overall the conditions are remaining relatively stable. And that takes us back to that dynamic equilibrium that Catherine talked about in the first activity. So we've got one with the increased precipitation, which leads to higher river discharge. That leads to the removal of excess water from the system, and that leads to reduced flood risk over time. We've got 7, higher soil moisture, which increases evapotranspiration. That leads to more water return to the atmosphere, and that reduces soil moisture surplus. And then we've got heavy rainfall, which increases infiltration and groundwater recharge. That causes a delay in release to rivers, and that reduces that peak discharge, obviously that highest amount of discharge in the river. And the last one is warmer temperatures, which increases that evaporation. That leads to that greater cloud formation through condensation. That increases the albedo effect, and that then increases the cooling as well. So some really good answers down there. We've got a couple of people who said they're not really sure that they've done that before. So positive feedback, again, we've got the questions come up in the chat. Positive feedback is about increasing the level of change that's going on. So in this case, it's making something worse. It's creating a chain reaction. So if we have a look at those 4 examples there, we've got the rise in temperatures. That increases the evaporation that's happening. That means there's lots more water, atmospheric water vapour happening there, and then that leads to that enhanced greenhouse effect, and you get that further warming. So it is when one negative thing in this case triggers another negative thing, which triggers another negative thing, and it knocks that system completely out of balance. Whereas the negative feedback is reducing that change, and it is restoring that system to balance. So it is creating dynamic equilibrium that we talked about before. Okay, and Catherine has popped in the chat that the positive feedback is a change that takes the system away from the equilibrium, so it stops it being balanced. Okay, we've got lots of notes on our website about this. We've also got some 60-second videos on our Tutor to You channel as well that does focus on feedback. So do have a look at those, because it is quite a complex idea, and often because when we think of positive, we normally think about something that's actually really good. And in this case, it's not. It's making a system unbalanced, and I think that can be quite confusing for some students. Right, Catherine, I'm going to hand over to you for our big reveal activity.
Yeah, wonderful. Yeah, with the feedback stuff that we were just talking about there, it is worth going to look it up, and there's loads of free resources on the Tutor2 website. It's often something that you can build into your 20-mark answers. If you're asked about things like tackling climate change, you can talk about how if we understand what is causing the system to go further away from equilibrium, we can stop doing those things. And if we're thinking about what can bring the system back to equilibrium, we could start doing those things. So if you've got those sort of concepts at your fingertips to build into your 20-mark questions, it builds an extra level of sophistication into your answers, which is going to really help you get those higher marks. So strongly recommend going and having a little look up on that, because there's lots of different stuff out there, and it's a really good thing to know. So what we're going to do now is we are going to be doing a bit of a big reveal. What's going to happen is there is going to be, first of all, one clue will be revealed, and see if you can have a guess at what we're talking about, and then more and more clues will be revealed. Can you work out what is hidden behind the question mark before all of the clues are revealed? Let's give it a go. Let's have our first clue. Right, so this condition exists when a system remains stable overall despite continuous internal change. I think some of you are so clever, you're going to get this really quickly. It's maintained through negative feedback mechanisms that counteract disturbances. What could this be? So it's about the inputs and outputs when the system are balanced, even though there are flows continually occurring. We've got that balance in the system. What could we be looking at here? So in the global hydrological cycle, it explains how the constant water storage remains total water storage remains relatively constant. Right, okay, so I think we got an answer there before the last one was revealed. I think that Mia got in there with the answer. It's when the water cycle stays in balance because gains and losses are equal over time. And Mia is our champion at getting the answer. Let's reveal. Yes, well done. Right, so Mia got in there, and then we got Charlie getting in there with dynamic equilibrium. Brilliant, that idea of balance. Great stuff. Well done, team.
It was quite handy we were just talking about that as well, wasn't it?
Yeah, it links in really well. So, can we be absolutely super again? So, this concept compares inputs, outputs, and changes in storage within a system over time. What could this be? Influenced by climatic factors such as precipitation, evapotranspiration, and seasonality. And we've got surpluses and deficits occurring depending on variations of weather conditions. This is again linking back to one of our earlier questions that we had. So it can be used to explain river regimes and flooding patterns. What are we looking at here? The balance between precipitation, evapotranspiration, and changes in water storage. So what are we thinking that this could be?
I'm just going to leave it for a moment to reveal. Oh,
Yeah,
we've got something. What do we think?
almost.
Maybe change one of those words.
Yeah, getting close there. Ninga's getting very close.
Yeah, here we go.
Right, and Doody Daniel again. So, right, the water budget. So, like I was saying earlier, this is something people often, sort of gloss over when they're revising. Make sure you know about this. It can be something that can come up on the 6-mark questions where you have the diagrams to analyse, or it can come up in other places as well. But definitely take a good look. So, well done to Doody Daniel. Fantastic. Right. Okay. So, So we're looking now at a graphical tool used to analyze how drainage basins respond to a precipitation event.
I think a couple of people might get this one quite quickly.
I think so, looking in the comments. So we've got interaction between basin characteristics. That's talking about the drainage basin there. Geology, relief, and land use. Remember, relief is the shape of the land. And on this graphical tool, we have a rising limb. We have a lag time peak discharge. Yeah, I think we're going to get people getting this already. Excellent. Yeah. So we have got the river discharge changing over time following a rainfall. And you have definitely got this one. It shows the river discharge in response to a storm event. It is all about flood hydrographs. Brilliant. Well done. And again, these could be something that could come up as a 4-mark question. It could be asking you about, outline the key characteristics of a flood hydrograph. But you often get these coming up in the 6-markers where we're talking about looking at a figure and then talking about what we can analyze from that figure. So make sure you know your flood hydrographs. Wonderful. Well done.
Okay, so we're going to move on to a bubble quiz now. So you may have come across this. It's a bit of a multiple choice question, but rather than just having one answer that is correct, the number of answers that are correct can range from none at all to all 4 of them. So let's have a look at our first one. So our first question is, which of the following are water stores in the global hydrological cycle? So if you just pop the letters down into the chat that you think are correct, which of those 5? So we've got atmosphere, cryosphere, we've got the oceans, and we have surface runoff. So just give you a moment to get those into the chats. So which of the following are water stores in the global hydrological cycle? Okay, so our first answer has come through as B and C. Then we have got A, B, and C. We've got quite a few people coming through now with the same. So let's have a look and see whether you are correct. Yeah, we've got atmosphere, we've got cryosphere, and we've got oceans. And obviously surface runoff is a transfer. So that's the water returning back to the oceans over the top of the land. So sometimes known as overland flow. Okay. Which factors are most likely to increase river discharge following rainfall? So we have steep relief, we've got frozen ground, we've got dense vegetation cover, and we've got impermeable geology. So which of these are most likely to increase river discharge following rainfall? So what do we think? Okay, just give you a moment to get these in. Okay, we've got a couple of people who think all of them. We've got a couple of A, B's and D's. We've got a couple of A's and C's. Let's have a look and see how you have done. Okay, so steep relief, frozen ground and impermeable geology. Dense vegetation cover will actually increase infiltration and interception, so it will slow down the river discharge increase. Number 3, which statements correctly describe dynamic equilibrium? So we've come back across this again in the global hydrological cycle. So we've got stores remain constant with no movement of water. Human activity cannot disrupt the system. Inputs and outputs are balanced over time, and feedback mechanisms help stabilise the system. So which of those statements correctly describe dynamic equilibrium in the global hydrological cycle? So again, just give you a moment to have a look at those and have a think about which ones they are, and if you pop them in the chat. So we've got C and D coming through at the moment. Okay, got another one for C and D. Okay, I think we all seem to be in agreement there. So you are correct, it is those two. The inputs and outputs are balanced over time. Feedback mechanisms help stabilise the system. Excellent, well done. Number 4, which characteristics are most likely to produce a short lag time on a storm hydrograph? So we've got gentle slopes, we've got thick soil cover, high drainage density and urban land use. So which of these are most likely to produce a short lag time? So again, pop your answers into the chat when you're ready. So we've got C and D again. Okay, we've got a couple of people coming in with C and D. Let's see whether you are correct. Yeah, it is those two there. So we think about the short lag time. That means there's less time between the peak rainfall and less time between the peak rainfall and the peak discharge. And that's down to a lack of infiltration in this case. And obviously, if you've got a short lag time, that means that you've got an increased likelihood of flooding. Right, we've got one more question before I hand back to Catherine. Which of the following human activities can alter flows and stores within the water cycle? We've got urbanisation, we've got construction of dams and reservoirs, we've got wind energy generation, and we've got deforestation. So which of these 4 activities, so human activities, can alter flows and stores within the water cycle? Okay, so far we've got A, B and D coming through. Quite a lot of you are in agreement with that one. So let's see whether you are correct. Yeah, we've got urbanisation. Obviously, when urbanisation takes place, then you've got areas of land being covered in tarmac and concrete, which are impermeable. So that obviously increases surface runoff. When we think about deforestation, you've got less you've got less vegetation for root uptake, but obviously for interception as well. And then we've got this construction of dams and reservoirs that we know massively alters the hydrological cycle there. Right, I'm going to hand back to Catherine now for our 5th activity, which is our 30-second challenge.
Okay, so you are going to have 30 seconds to answer the question that comes up. So lots of quick thinking needed. Which factors increase the risk of runoff? Dramatic music, love it. Right, let's put this distance in. Increasing runoff. What is it going to be? Okay, right. Okay, brilliant. So, we got nice and quick again. We got Harry coming in there with impermeable surfaces. Oh, brilliant. Soccer fan there with steep slopes and impermeable material. We've got urbanization coming in there from Noah. Mia is back again, being amazing with higher rainfall, impermeable surfaces, steep slopes. Fantastic. Vicky, what have we got that's on the list? I think that our team have got pretty much all of these. That is absolutely brilliant. What superstars they are. So yeah, so a nice term that we've got there on the screen with intense rainfall. I'm changing my vowels again, Vicky. So when we got intense rainfall, think about exceeding the infiltration capacity. Love that term. So water can soak into soil, but if it's coming down at such a rate that it won't soak in, then we're going to get problems. The soil could also get saturated and we're going to get that runoff. We've got the impermeable geology, such as granite. We've got those steep slopes that you've mentioned, the deforestation, which removes the interception, and you brilliantly talks about urbanization and impermeable surfaces. So you've done a great summary there. Fantastic. Shall we try it again? How do natural changes affect the water cycle? So it's easy to think about the man-made ones, but about the natural ones. Very stirring music, getting our brains racing. Quite hard sometimes to think about the natural changes rather than the man-made ones. Right, okay, fantastic. So let's see what you are coming up with this time, you absolute superstars. So it's quite tricky. We think about the water cycle. We often think about things that people do that affect the water cycle. But we need to also think about natural changes. And also, as well, when we're thinking about these changes, we can be thinking them over different time periods. You get, again, particularly in your 20 mark answers, if you're thinking about how changes can happen over time, as well as happening from place to place, that can be really good. So, right, we've got lots of suggestions here about precipitation, about temperatures. So let's see what we've got to reveal to the gang. Right, brilliant. Okay, so you've talked about things like climate changes. You talked about precipitation patterns. You were talking, it would be stronger in your answer there if you're talking about when we're thinking about the natural changes, what is it that's causing those changes to the precipitation patterns? So thinking about things like an El Nino event might be good. So we're thinking about the changes to precipitation, also to the evapotranspiration. We do have natural changes as well affecting vegetation. So we talked in the previous one about things like deforestation, but you're going to have in deciduous woodlands, you're going to have seasonal leaf fall, and that is going to affect the processes that are happening as well. And then we've also got, I think it was Emma that said about cold climate. So well done for that, because you are going to have cryosphere change, cryosphere being the word of ice. And so you have advance or retreat of snow and ice, and how that affects things like glacial storage, and will have a knock-on effect on the rest of the system. So that is a bit of a tricky one sometimes. So I think that's brilliant that Vicky's popped that in here to get us thinking about it. So this one I think is a bit easier. How does human activity impact the water cycle? Brilliant. Getting these ideas coming in. Fantastic stuff. Right. So yeah. So we've got some ideas coming in here. I thought you'd find this one easier. Isn't it funny that we often the human activity comes straight to our minds and it's harder sometimes to think about the natural change. Lots of people talking about urbanization. So well done. And also well done to Sam there talking about agriculture. We got deforestation coming in. So Vicky, what have we got on our list here? Right, fantastic. So yes, so we've got the urbanisation that a lot of you thought of that links back to our previous activity where we were thinking about impermeable surfaces, reducing the infiltration. We've got deforestation where we got the reduced interception and evapotranspiration. And one that you didn't mention so much, actually, Emma had popped on there about water abstraction. So taking water out of the system for people to use it for things like agriculture or for drinking water or for industry, that is going to change what's going on with the water in the system. And also dam building, of course, is going to have an impact on that as well. It looks like there's a couple of you that have done some very, very thorough revision already and have got really good knowledge. Well done.
Okay, so our last activity is a nice easy one to end with. So we've got some true or false statements. I think we've got 8 of them. So we just need you to put true or false or even F or T in the box when it's appropriate. So our first one is water stores in the global hydrological cycle include cryosphere, oceans, lithosphere, biosphere and the atmosphere. Is that true or false? Nice easy one to start. Okay. Okay, so we've got some trues coming through there. Well done. So that's a nice, easy one. They are all water stores. Okay, second one. The global hydrological cycle is a closed system, so human activity cannot affect it. Is that true or false? So again, I'll give you a couple of moments to get your true or false in. Okay, let's have a look. Oh, we've got some no entry signs signifying false here. Excellent. It is a false. We know that human activity can and it does affect it. So the total amount of water on Earth is constant. So we sometimes call it a closed system, but the human activities themselves obviously can alter the stores and flows and the pathways within the cycle, and they can change how and where that water moves. So we think again about some of the examples we've already talked about. Deforestation affects interception and it affects evapotranspiration, which increases the risk of flooding because it increases surface runoff. We've talked about water abstraction and dams because they alter river discharge and they disrupt transfers between the stores. So we know that human activity can affect it. Okay, next one. High rainfall always leads to a high river discharge. Is this true or false? Okay, what do we think? Okay, so we've got some good answers coming through again. Does it always lead to high river discharge? So we've got some false coming through. Let's have a look and see. Yeah, it is false. So it doesn't always lead to that. The relationship is influenced by several physical and human factors within that drainage basin that we covered in that 30-second challenge. So for example, what we might think about the vegetation cover, inception by vegetation or increased evapotranspiration can significantly reduce the amount of water reaching the river. So even if it has rained quite heavily, that might not necessarily mean that the river discharge is going to increase. And again, we've talked about human activity in terms of like building reservoirs and dams and abstracting water, and that can obviously have an impact even if there's been high rainfall. Okay, next one. Deforestation reduces flood risk because there is less interception. Is that true or false? So deforestation reduces flood risk because there is less interception. Do we think that's true or false? just give you a moment to pop those up. Yeah, again, we're coming through as false, and you are correct that it is false. So we know, hopefully, that deforestation actually increases that risk of flood risk. We know that there's less interception, and that interception by vegetation will slow down the movement of rainfall, and it allows more time for infiltration. So when those trees are removed, then the rainfall reaches the ground more quickly, which means obviously that increases that risk of flooding. Okay, next one. Evapotranspiration combines evaporation from the land surface and transpiration from the vegetation. So we have come across this word a lot in all of our activities tonight, and we've talked about it, but we've not actually given you a definition, and the reason for that is because of this last activity. So is this true or false? Okay, let's have a look. It is true. Okay, so we know that those two processes, so evaporation, nice, simple, straightforward process. Transpiration is the loss of water from vegetation. Combined, that creates evapotranspiration. Groundwater moves too slowly to have a significant impact on river flow. Is this true or false? Okay, so we're coming through again with false on this one. Let's see if you are correct. Absolutely, it can make a real contribution to river flow, especially over a longer time scale. So we think about that groundwater, it's providing a base flow to the rivers, and it maintains discharge during dry periods when there's little or no rainfall. So it does move slowly, but it is stored in large quantities, so it has almost like a cumulative contribution to rivers, and it is quite significant. Okay, we've got a couple more to go. Water scarcity only occurs in hot, arid regions. Is this true or false? Okay, so just give you a minute for that one. Okay, so we've got some false coming through. Let's see if you are correct. Absolutely, it can occur in lots of different types of climate. It's not just hot, arid regions. So we know in this country alone that we do sometimes have water scarcity when we have hosepipe bans in times of drought. We had that last summer, and it can be obviously quite seasonal. So we might have a temperate climate like the UK, where we have lots of rainfall at certain times of the year, like now, but maybe in the summer we have a long period. So we know that it occurs a lot in those hot arid regions, and it occurs probably all year round for many of those, but countries like the UK, we also get it from time to time as well. Right, last one. Our last one is climate change has no effect on the total amount of water in the global hydrological cycle. What do we think? Well, this one seems to be causing a little bit more sort of difficulty. So we've got some trues. Oh, we've got true and a false coming through. Mainly trues coming through, but we have a little bit of debate on this one. So this one is true because it does not actually add or remove water from the Earth system overall. Remember, it is a closed system, so no significant water enters or leaves the Earth, but it does redistribute water between the stores, and it alters flows. We know that more evaporation, for example, leads to heavier rainfall, increasing glacier melt, etc. But it doesn't actually change the total volume of water on the planet. However, you could argue that it could be false depending on how strictly and critically it is interpreted. So if we're thinking about the higher level evaluation, perhaps for a 20 marker, you could talk about climate change causing the long-term loss of water from terrestrial stores, for example, the melting glaciers and the ice sheets which transfer water into the oceans, and the fact that this reduces the amount of fresh water stored on land. and even if the global total stays the same, that's it, reducing that. You could talk about how some water is temporarily lost from the active hydrological cycle, so that increased atmospheric water vapour, for example, deeper oceanic storage, which is less accessible. So you can argue both sides, which is why that was coming up as true and false from lots of you. Okay, so well done. We've had some really great interactions from you guys tonight. I had a question a minute ago that came up. I'm not sure who asked it, about whether there was a schedule for the sessions. There is a schedule. I'm not sure whether I put it on the Instagram page on every Sunday or Sunday night or Monday night. I'm not sure which one it was now that I'd scheduled. There's a post that tells you which one is coming up this week, but what I will do once we get off is I can pop a post on telling us when they are for the next 14 or the next 13 sessions. So thank you so much for all of those of you who joined in. We've had at least 10 of you that will contribute regularly, possibly even more. We had some really good questions from you and some really good answers. So yeah, I think it's been a successful first one, don't you, Catherine?
I think they have been absolutely phenomenal, and I really hope they're all going to be coming back every week, because
Absolutely.
it is such a pleasure to be able to do a session like this and have so many people putting answers in and just getting involved. It's so much better when you get involved rather than just sitting there being passive. Just generally with revision, full stop.
Yeah, agree.
Get involved. And Vicky, I just checked on the Instagram page, and the individual posts have been up, but you put one on Facebook that said all the timings, and that hasn't been on Insta. So
I'll pop
if
that
that goes on Insta, and then everyone can have a little look, and then you can keep joining us for sessions. Would be wonderful, because you've been an absolute delight.
And next week we are doing another core topic. We're actually doing paper 2 next week, and we're going to do global systems next week. So that will be at 6 o'clock. Are you doing that one, Catherine, or I can't remember who's down for that one?
Oh my goodness. Oh my goodness. I hope I am, because I love that topic. I don't think I am doing that one, actually. I think someone else must have whipped in a bagseed that one first, but I will double check.
Yeah, so it's on 6 o'clock next week, Wednesday. We remember, obviously, if you've just tuned in and you've missed most of the session, you can watch it on playback. But there are also, if you have a look at our Tutor to You channel, there are around about 80 of our previous live streams from the last sort of 4 or 5 years. We've done a lot of these. So hopefully we will see you next week. Well done, all of you, for contributing, and I hope you have a lovely, lovely evening. Okay, bye-bye.